Hi everybody. It's been a quite while. I paused my lessons. Sorry about it. I got a really busy situation and I couldn't find a single minute free to do my lessons to you. So sorry about first of all. So yeah, let's get starting. And today we are going to start to learn deep learning. Yeah, I know this is a very hard topic, but I guess this can give you a great bit of idea about how machine learning works and a lot of things can work. So I guess it's not a best starting point, but one of the good starting point to understand how deep learning works. Then go to how machine learning works because both machine learning, artificial intelligence all works in the inside the deep learning. Not really, almost all deep learning, something like that. So first of all, we need to know there's a single diagram. We call it a single diagram, and we call this is AI, artificial intelligence. But this artificial intelligence actually says that it's we. It says that any machine that can do human what human can do. That's the kind of intelligence that artificial intelligence is actually proposing of. Inside artificial intelligence, there is machine learning, and machine learning is saying we don't have to write a lot of codes here, a low code, and doing the exact stuff that need to solve some of the some of the predictive problems. And inside that, there is deep learning. Don't seem this is a very small language, but this actually takes a large importance in the field of artificial intelligence. And deep learning is actually saying is the in-depth knowledge. It does have every single kind of things. It actually says, it actually does every single thing. It actually takes, it's a hard coded a bit, but it has a lot of calculation with matrix multiplication and algebra summations. So that's the thing why deep learning is so special. In order to make ML work, some of the deep learning concepts are used for the ML solutions. And apart from that, deep learning is said to be like a something called a study of neural networks, like our human brain works. In deep learning, we create the neurons and we create the brain to do every single kind of things that we need to solve. So we are going to learn about neural networks, how it works, and why does it actually outperform most of the machine learning algorithms in some problems. You cannot say all problems in deep learning are the best, but for most of the problems right now, deep learnings are the best right now. So let's get started. So the first thing you might why does it right now have deep learning ML is actually here in every single places. Whenever you go for a website, they say this is powered by AI or something like powered by machine learning or something like that. Why it is now? You might just wonder. You might think that this kind of fiction has actually been taught from long before from some of the literatures. But why does it right now? Do you know when did the artificial intelligence was actually founded? It's in 1956. Intelligence was discovered in 1956. But why now? Why didn't they have a development in the 1956? And there comes the first thing, we didn't have enough data. First thing, we don't have enough data. We don't have the storage to save them. Right now we have like TB, BT, petabytes, so many other things. We have a large amount of memory capacities. But right in the 1950s, we had a lot of memory capacities. That time, the people were using like floppy disks, CDs, some no USB wasn't founded, and such a kind of things were very limited. So that's the thing. There is no enough data and there is no enough data enough memory to store them as well. And why deep learning right now is the other thing is deep learning needs, algorithms needs a lot of computing power. It takes a lot of computing power to train or just to make the neural network understand what the problem is and exploit them. And that's the thing, we need a lot of computing power. But back then we had a lot of memory. We say we had just like 512 MB RAM. I have a computer of my father here, which is a 500 MB RAM of 256 MB RAM, something like that. So it's back then, how do we do this kind of operations in a very large systems? And that's another thing that made it even impossible to make it um, to develop the deep learning algorithms. The rest of the other things were they weren't quite a framework where people can do every single kind of things easily. When did the Python developed? That is on 1991, and we don't have a quite an easy language to actually develop them. And before that, other kind of things were actually a problem. We were using like a machine code, and it's very very hard, and people were just like, oh, that's gross, something like that, to artificial intelligence. Or even though the idea of artificial intelligence are marvelous and fiction. And back in 1958, the first perceptron, which means called the learnable weights, were developed. Then it comes to 1986 when the back propagation. I'll be saying what the perceptron, the back propagation in the later videos, but it was developing that kind of things. And back propagation, one of the most best thing about the deep learning algorithms that makes it apart from all the algorithms, how it learns and how it actually achieves a great score. And that's the thing. And back in 1995, or I think 1995, the deep convolution network was found by Ian LeCun, and it was a marvelous thing inside the computer vision and the audio, and a lot of things were actually being benefited from the deep convolution. And that's the best part, and that's when the development starting from 2000. That means the 21st century, and that's the reason we didn't have quite a bit of language to develop them. And that is during 2000 we called new models, new type of frameworks called TensorFlow, PyTorch, and a lot of other things. And that is when the development of AI or deep learning starts, and more the applications coming like the face generation, face aging, and just changing the gender or everything kind of things we see in these days. And it seems like amazing right now. How did we develop such a kind of applications? And I said we don't have enough software at that time, but we have a software right now called PyTorch. Another software, there are several software, TensorFlow, there is Piano, there's Keras, it is right now, and Piano is inside Keras as well. There's Cafe, there is Jax right now, it's developed, and there is other things, I forgot about it. There is other things like DeepMind kind of architectures, frameworks, and a lot of other things. I don't know what's the name of it, but it's amazing. There's Paddles framework, and it has a lot of pre-trained networks right now, like EfficientNet. I'll be talking about it. We won't be going what is pre-trained networks and every single thing. I'm not going too far. And in this course, we'll be using the PyTorch library, and I'll be having a TensorFlow as a separate topic. I've been using PyTorch as my best for it because why I'm preferring PyTorch is because it isn't fast than TensorFlow, but it's dynamic, and it actually teaches us how neural networks actually work. Because its coding is a bit long, but it's very easy and it's very understandable. And for TensorFlow and PyTorch are dynamic, while TensorFlow is a static one. We often have some debates against PyTorch TensorFlow right now. I prefer PyTorch my own. I don't say that TensorFlow is the best one or PyTorch is the best one. But both has its own advantages. TensorFlow is fast, but in order to learn, PyTorch is the best. It's dynamic. You can just manipulate the code much easier than TensorFlow, I guess, from my side. And that's the thing. That's why I just actually prefer PyTorch. I need you to know some of the concepts about deep learning as well. Deep learning networks need GPUs, which stands for graphic processing unit, which some people call it graphics card, some people call it a different name. I don't know what it calls. It doesn't matter. But and that's the main thing about uh, deep learning. Would make how the deep learning development starts from, and GPUs like from NVIDIA, AMD, any GPUs is needed to actually train. We can just train them in CPUs if the network is so small, but you need to make it even more. The training to make it faster, you need to use some kind of GPUs. And right now we have DPUs as well. And last time I said TensorFlow was good in TPUs. PyTorch have a good framework, but still, I guess my side is still broken. Not really a most easy manner to use them. It doesn't work in all time. So I guess TensorFlow has an advantage over TPUs, which is more faster than GPUs. So in order to train, we just actually do some kind of these things like that. So before that, we can also train the network. We call the terms called train, infer, which is also called test, sometimes validation or valid, epochs, all these things. The train say we are training the network to adapt to that problem. We are just actually giving a bunch of samples to it, and we are saying to deep learning network that you should learn these samples and find your own patterns in it. Yeah, that's the thing that it does. I will show you one of the advantages of training a deep learning. Before that, I'm just actually say what's inference test. After you train a network, the model knows what the problem is and how to solve the problem, how to exploit them, and you need to put them to the people to see the people to actually say that your network is the best, something like that, and you need to test them. Just take that trained network and give it to the people to use them, and that's where inference or test is coming. The validation part is one of the hardest parts sometimes, which is mostly used in competitions and in the business field as well. We need to validate. Sometimes validations just actually says that you need to improve your model based on the validation, because validation means it's a set that model has never seen. It can always learn from the data that it was given, but it can never learn from a data that it has never seen. And we can just test them and we can just bring the best model. I'll be saying it again in the future lessons. Other thing is epochs. Epochs are the number of times you train the network on the same data. You give the data once and it sees that it finds some features. The next time it finds another kind of features, and each time we give this kind of things, how many times we do this, sometimes it get better, sometimes it get lower. We'll be seeing such a kind of examples in future, and the number of times is called the epochs. We were using that term a couple of times, and I'll be showing you a picture in the next slide. This is one of the picture from the MIT's in deep learning course, and this is how why deep learning is so special. You'd find the features in its own. See, in this feature, they find the line and edges by its own. But what if you are just actually coding them out with your hand? It will be a very time consuming, maybe not the best one. A lot of things can happen wrong. And just actually see the mid-layer features, it actually detects the nose, the eyes and ears, every single thing, and it makes you, if this is a program that detects your face and detects your mobile, you have seen in sometimes you've seen in mobile phone that it detects sometimes your photo from it detects, this is a photo of Rizin, it's a photo of John, it's a photo of Kumar, something like that, and it says we actually distinguish them with their eyes, ears and nose sometimes, and they have high level features like the shape of your face, the facial structure, something like that things. And these are the best features that deep learning is right now very much concentrated or very much developing and um, very much like, yeah, amazing field. And this is what we are going to do. We are just actually teaching the network to detect your face, and it should find your own features, what makes you different from others. And we are going to just check out the next few lessons how deep learning algorithms are going to work. Before that, we have another kind of thing. We call it as multi-GPU training. I'll be saying it after a few days after. We're not going to do this thing. So multi-GPU training is you have one neural network. Okay, just think this is a neural network. It's a complete one, and yeah, we are taking this network in a GPU. And we put in the images inside of it, and we get this is an apple. So this is a GPU. What if we have a single GPU having the model and we give several GPUs to train on them? If you have a lot of data, if you have a big network to train, you might need to use multi GPUs. They get sharing the same network, and they just actually take the same data on different GPUs and get the results on the one single GPU for the loss or something like that. Before that, I'm going to show you how machine learning is going to work from the usual programming. It will be an amazing thing. Suppose you guess you have a samples of apple, okay, and you have an apple which is bited by one person. You have a green apple, but your program need to find whether this is an apple or an orange, or an orange. If you are hard coding them, this will say this doesn't have a shape like this one, and this doesn't have a grid color, and they say this is not an apple, not an apple. What is say? But this is an apple. And this is an apple. Just say this is an, or if you say like this is a mango. We hard coded them to actually find, like we hard coded say an apple can have a shape something like this one, and it should be a red in color. But what if someone bites, its shape is done and its shape is whatever you say the mango is kind of shape is saying. And if the person bites in the shape of a mango, it says mango, even though it's red color. What about orange? If the color of an apple, like the cow, it doesn't fully ripen, then maybe the color will be like orange color. You would say it's an orange, but still it's an apple. Maybe the color of an orange comes to red, or it's come to green, then what say? It's an apple. In such a kind of cases, we have to do every single kind of features that apple can have. But what is, we give all the features for the apple here, for the orange here, for the mango here, all the things. But do you know what does this do? What does deep learning do? It does something like this one. You put the same features inside of this one, it will find the features for you. And that's the speciality of a deep learning. And that makes a deep learning a way more applicable to most of the problems. Nowadays, it's used in a lot of applications. You might have used the Face app. We have used the what do we say that we have used it for changing the image, changing the photo. We have just actually enhancing the images for editing, so many other things. And like in videos, we use in self-driving cars. And another kind of example is the deep fake. It's one of the biggest example. You might just actually go to YouTube and just try the deep fake, and you can see that we can speak whatever person should speak. If you need Elon Musk to say that you are the best, your name is best, like my Muhammad Rizin is the best, you can do it like that. And that's the amazing thing about deep learning. And you'll be doing to do so many applications, so many projects in deep learning in the next few days, or so next in this month. And good luck.